Hello, today we are going to be working through lesson 13-1, Angle Relationships in Triangles. Our learning targets today are to prove theorems about angle measurements in triangles and apply theorems about angle measurements in triangles. Okay, so let's get started. The architectural design of a Rock and Roll Hall of Fame in Cleveland, Ohio includes triangles. Some of the glass panels on the facade need to be replaced. To cut the glass correctly, angle measures of some of the triangles will need to be determined. Jason owns a glass company that he will be cutting the glass for the repairs. One of the tools he will use to determine angle measurements of the triangles is the parallel postulate. So we're going to be using parallel lines to figure this stuff out. Jason cannot remember the sum of the measures of the angles of triangles. He begins by drawing one of the triangles of glass he needs to replace. So, number 1, in your book, please draw or trace the triangle below. So we're just getting used to working with triangles. It's a little rough trace, but that's okay. So next on part 2 it says tear off each corner of the triangle. I'm just going to do this for you. So as you can see, we have a triangle ABC. We cut out this triangle. This works with any shape of triangle. Now we have our vertices A, B, and C. And we're simply going to cut those vertices out. So during this time you can be having a discussion. What do you think is going to happen? So if we take vertices A, B, and C, and you line them up next to each other, how many degrees does that make? Well, as you can see, it makes a straight line, like she drew. And from Unit 1, we know that a straight angle or a line is 180 degrees. So these 3 vertices of the triangle add up to 180 degrees. So if we go back to our book, we can see that part 4, what appears to be true about the sum of the measures of the angles of the triangle. We now know that the angles of the triangle add up to 180 degrees. Sum of the measures of the angles of a triangle is 180 degrees. And on number 3, if you want to draw just a little rudimentary picture, that works. This is angle 1, 2, and 3, or vertice 1, 2, and 3. Okay. Now if you turn the page, we're on page 182 now. It says you must have made a conjecture about the sum of the measures of angles of a triangle, but the conjecture is not proven. Jason wants to prove the relationship and be absolutely certain he is correct. So we've made a conjecture, we figured it out. Maybe some of you remembered from previous lessons that it's 180 degrees. Well, now we want to actually prove it. Okay, and how do we prove things in our class? We've been using two-column proofs. So number 5 says, make use of the structure. When you're given a figure for a proof, you cannot change anything in the figure, but you can add a line to the figure to help you complete the proof. A line used in this manner is called an auxiliary line. The proof of the triangle sum theorem begins by drawing an auxiliary line D that intersects point A and is parallel to segment BC. Line D forms angles 4 and 5. Okay, so basically this is just saying that we can't change anything about our proof, but we can add an extra line right here. Let's see if I can do this. Line D, actually this would be segment D, in order to create this two-column proof. Okay, so I just drew my line D going through point A, intersecting at point A, and it's parallel to BC. So that's what I drew. So I'm going to add it to my proof down here. You should be doing so as well in your book. So line D is parallel to segment BC. Okay? So number 6 says complete the proof of the triangle sum theorem. The theorem, the sum of the angles of the triangle is 180 degrees. We're given its triangle ABC, and we want to prove the measurement of angle 2 plus the measurement of angle 1 plus the measurement of angle 3 is 180 degrees. We want to be able to prove that angle 1, 2, and 3 add up to 180 degrees. Okay, so if we look down here, statement 1 says, through point A, draw AD so that AD is parallel to BC. And if you look over here, the parallel postulate, if you read this, it basically says that through any one point you can draw one line parallel to another line. And that is what we did. So our reason for doing that is through any point not on a line, there's exactly one line parallel to the given line. So that's saying through point A, there's only one line we can draw that would be parallel to BC, and that is our line D. And then number 2 says the measure of angle 5 plus the measure of angle 1 plus the measure of angle 4 equals 180 degrees. And we know this because of the angle addition postulate that we learned, I think, in Unit 2. Okay, so next we need to come up with our next statement. And our reason for it is if parallel lines are cut by a transversal, then alternate interior angles are congruent. So if we're looking at this image and we're looking for our alternate interior angles, we've got angle 5 and angle 2. If you see, they're alternate interior angles. So I know that angle 5 must be congruent to angle 2. Then over here, I've also got angle 4 and angle 3. And I know that those are alternate interior angles as well, which means they are congruent. And my reason is stays the same. Then number 4, we've got to come up with our next statement, where the reason is the definition of congruent angles. Okay? So basically, we want to be able to use these angles to substitute into our equation. So instead of saying congruent, we're just going to go angle 5 is equal to angle 2, and angle 4 is equal to angle 3. Because on step 5, we want to be able to substitute these angles in. So we're already given an equation. So up here it says the measure of angle 5. Well, we know that angle 5 equals angle 2. So instead of saying angle 5, we just put the measure of angle 2 plus the measure of angle 1 plus, we just proved that 4 is equal to 3, so the measure of angle 3 equals 180 degrees. And lo and behold, that is what we're trying to prove. So using the parallel postulate, we were able to prove, in fact, that angle 1, 2, and 3 added together is 180 degrees. So in groups or partners or something of the sort, I want you to check your understanding right now. So go ahead, pause the video, read through 7, 8, and 9, and see if you can discuss this with your groups or partners. Okay, so hopefully we went through 7, 8, and 9. Quickly, I'll discuss it with you. Number 7 says, in the proof of the triangle sum theorem, what we just did, could auxiliary line D have been drawn through vertex B or vertex C instead of vertex A? Explain. Hopefully, all you guys said yes, because you can use any of the vertices to prove the theorem. By drawing a line through point C, it would have to be parallel to segment AB, or by drawing a line through point B, but it would have to be parallel to segment AC. Okay? So number 8, how can you use the triangle sum theorem to show that the measures of each angle of an equal angular triangle is 60 degrees? Okay, so how could you use this same thing to show that all of the angles are 60 degrees? Well, I'm just going to write it out over here. So if we have angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3 equals 180 degrees. We're trying to prove that each of these are 60 degrees. Okay, so if all 3 of these are equal, we can just substitute in. We can say that the measure of angle 1 plus another measure of angle 1 plus another measure of angle 1 is still equal to 180 degrees. So 3 measures of angle 1 is 180 degrees. Therefore, if we divide by 3, the measure of angle 1 is 60 degrees. And if the measure of angle 1 is 60 degrees, and we already established that they're all congruent, that means the measure of angle 2 is 60 degrees, and the measure of angle 3 is 60 degrees. Then number 9 says, how can you use the triangle sum theorem to show that the measures of the acute angles of a right triangle are complementary? So I'm going to erase this because I don't have quite enough room on my paper, but hopefully you guys left some room. So again, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is still 180 degrees. But it's a right triangle, so we're going to put angle 3 as our right angle. So we've got measure of angle 1 plus the measure of angle 2 plus 90 degrees equals 180 degrees. Well, if I subtract this 90 degrees, I've got the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Therefore, it is complementary, because if you recall from one of our previous units, complementary angles are two angles that add up to 90 degrees, which is exactly what we just did. Okay, so let's go to our next page. We're on page 183. Alright, so what have we got? An interior angle of a triangle is formed by two sides of the triangle. Okay, so any of the inside angles obviously are formed by two sides. An exterior angle of a triangle is formed by one side of the triangle and the extension of an adjacent side. Okay, so we've got, this is an interior angle, and then out here we have our exterior angle. See how it's formed by one of the sides of the triangle, and then the adjacent side, this side next to it, the extension of that. So we've got our angle, our exterior angle right here. Okay, and then a remote interior angle of the triangle is an interior angle that's not adjacent to a given exterior angle. So that means that a remote interior angle, like a remote island, is way off in the middle of nowhere. A remote interior angle is way off away from our exterior angle. It's not adjacent. So we've got one remote interior and two remote interiors from angle 4. Okay? And then our situation says sometimes Jason will only know the measure of an exterior angle of a triangle. He needs to be able to determine the interior angles of the triangle if he knows an exterior angle measure. So if he's only given angle 4, he wants to be able to figure out what angles 1 and 2 are. So in number 10 it says label each angle of the triangle using one of the following terms. So right now go ahead and pause the video and label all these different angles what they are. And then when you come back we'll be on the next video and we'll continue where we left off.